So the next chunk of problems have some parentheses, and they're either adding binomials or trinomials. It's just more adding problems. These are problems that have parentheses that are almost wasted parentheses. There are 2 times that I can think of that I can write a problem that has parentheses by dropping the parentheses and not doing any altering to the contents of the parentheses. And the 2 times are if I have a parentheses that leads a problem that doesn't have a coefficient in front of it and it doesn't have an exponent. So if a problem leads with a parentheses, and after that parentheses is an addition or subtraction sign, if that parentheses doesn't have a coefficient and it doesn't have an exponent, you can just simply drop that parentheses without changing the contents. If, however, the parentheses had an exponent, the parentheses had a coefficient, or there was a times between the parentheses and what follows the parentheses, I couldn't just drop the parentheses. But if I have exactly this, a parentheses, no coefficient, no exponent, an addition or subtraction, not multiplication or division after the plus sign, you can simply drop the parentheses. So this is one instance where it's freebie to drop the parentheses. The second freebie is this. If I have a parentheses that has a plus sign between it, only a plus sign, not a times, not a minus, not a divide. If I have a parentheses that has a plus sign before it, no coefficient after the plus sign, no exponent outside the parentheses, that's the other case where I can just drop the parentheses without changing what's inside the parentheses at all. So problem leads with a parentheses, doesn't have a coefficient, doesn't have an exponent, has a plus or a minus after it, that parentheses can be dropped. A problem that has a plus sign preceding a parentheses, and that parentheses doesn't have a coefficient or an exponent, that parentheses can be dropped. So all of the problems between 17 and 26 fit that perfectly. The first term starts with a parentheses. That parentheses doesn't have an exponent. It's followed by a plus sign, but it could be followed by a minus sign. That wouldn't matter. And preceding it, it doesn't have an exponent. That kind of parentheses can always be dropped. If after a plus sign you have a parentheses and there's not a coefficient after the plus sign before the parentheses, and there's not an exponent outside the parentheses, that parentheses can just be dropped. Each of the problems between 17 and 26, the parentheses are redundant. They're not necessary. So I'm just going to drop the parentheses in problem 18 because I'm allowed to. And then I'm going to combine like terms. The like terms in 18 are the 3y and the 7y, and the 15 and the 8. All nice plus signs. 3y plus 7y gives me 10y, and 15 plus 8 gives me 23. So my answer to 18 is just going to be 10y plus 23. When I move down to 20, first parentheses has a plus sign after it. It could have a minus sign after it. I just can't have a times after it, or implied times, or divide after it. And doesn't have an exponent, doesn't have a coefficient. The first parentheses can just be dropped, and the problem will equal to the original problem. That's why I'm writing the equal sign, implying it equals to the original problem. Second parentheses has a plus sign before it, doesn't have an exponent, doesn't have a coefficient after the plus sign outside the parentheses. That parentheses can just be dropped as well. And I am going to change this a little bit. I'm going to put the implied coefficients of 1 in front of the x squared and the x, because that's going to help me combine like terms. Now I'm going to write this in a nice order. I'm going to write the minus 2x squared plus 1x squared, the minus 3x and the positive 1x, and the minus 5 and the minus 2. Now I'm going to combine the coefficients. The first coefficients are minus 2 plus 1. I'm going to get a minus 1 for the x squared term. So in my answer, I can write a minus 1x squared. Or if I want to suppress the 1, I can just write minus x squared. And then the minus 3 and positive 1x, if the numbers in front of the variables have opposite signs, you wind up subtracting and taking the sign of the larger. This is really 1 minus 3, which is negative 2. on my calculator, if I can't do that in my head, minus 3 plus 1. For the x terms, it's going to give me minus 2 with the x. And then the constants at the end here, they're both negative. If that's the case, I'm going to add them and keep them negative. If I did negative by the fraction 5 minus by the equal sign 2, that would tell me that simplifies to a negative 7. So because we don't know anything about factoring at this point, this would be a great answer for problem 20, or not having the 1 written and just having a negative in front of the x squared would be equally good for an answer. We don't know it yet, but some of you might have instinctively did this. You might have factored out a negative or a negative 1 and shoved it in front of a parentheses and did something that you may know, but you don't need to know yet. So if you instinctively did this, fantastic, you're way ahead of the game. That's what we learned in chapter 1. If you didn't instinctively did this because you didn't remember it or never learned it, don't worry about this. We're not asked to rewrite by factoring yet. 22, same deal. First parentheses doesn't have a coefficient, doesn't have an exponent, it has a plus after it. I can drop that parentheses without changing the contents, and it still equals to the original problem. Second parentheses has a plus sign preceding it, doesn't have a coefficient after the plus sign outside the parentheses, doesn't have an exponent. That also can just be dropped. And now from highest degree to lowest degree, I'm going to write these so I can combine like terms. I'm going to write the 7x to the 4th, and then plus 3x cubed, plus 6x cubed, and then the plus 2x, minus 7x, and then the plus 3. The 7x to the 4th needs to be written first. It's the highest degree term. The next two terms, I'm going to add the 3 and 6 and get 9x cubed. The last terms, or the second and third last, I'm going to go 2 minus 7 and get negative 5, or minus 5x. And then the last term of plus 3. That's probably the best way to write an answer. I could have written this, which would look odd to me, but if you instinctively wrote 7x to the 4th plus 9x cubed, instead of minus 5x, if you put plus a negative 5x, that's actually equal to, plus a negative is the same as a minus. These are both correct. The bottom one is odd, but it's correct. Um, 24, same deal. No reasons to change the contents of the parentheses. I can just drop them. First parentheses, no exponent in front of it. No times. There's times are divide after it. Plus or minus after it's okay. And no coefficient. So I'm going to drop the first parentheses and get 4xy minus 2x squared y plus 3x. Drop the second one and get plus 5x minus 6xy plus 7x squared y. Now write in a nice order. I'm going to write the highest degree term first, which is the minus 2x squared y, which is a third degree term, and the 7x squared y, which is another third degree term, first. And then the positive 4xy minus 6xy, which are second degree terms, second. And then the plus 3x plus 5x, which are the first degree terms, last. And now I'm going to combine. If the numbers are opposite, you subtract the numbers. So the minus 2 and plus 7 are going to give me a negative 5. It gives me a positive 5 because the 7 is positive and it's bigger. So I subtract, take the sign of the larger. 4 minus 6 is going to give me negative 2 in front of the xy. And then 3x plus 5x is going to give me an 8x. This would be the best answer for 24 because I've written everything in a nice order and I've combined the like terms. Last one on this page, and then we get to a group of problems that I don't particularly like. They're the same, but I'm going to solve them differently. In 26, first parentheses can just be dropped. Second parentheses can just be dropped. if I look at these, this is a fourth degree term, this is a fourth degree term, this is a fourth degree term, and that's a fourth degree term. There's no term that's crying out to be first. I'm just going to write the ones that's going to have a positive coefficient first. So I'm going to combine these, which are like terms, and because of the lovely positives, I'm going to write those first. I prefer, if I have a choice between first terms, because there's multiple terms that have the same degree that aren't like terms, I pick the positive first. This is garbage. This is supposed to be minus 11x cubed y. I'm not sure why they stuck that plus in there. The last set of like terms are the minus 11x cubed y plus 5x cubed y. These, when I combine them, I just add the 9 and 8 and get 17. I leave the xy cubed. I wrote it first because it's positive. And then the second, I'm going to do minus 11 plus 5 and get minus 6x cubed y. That term could actually be first. It doesn't matter that I wrote it second. So for my answer, these are the two terms I need. I could have written the minus 6x cubed y first and the 17xy cubed second. I guess if I have a choice, and because both of the terms left in my answer that are eligible for first have the same degree, I use the positive first. All right, I think we can do another chunk of problems before maybe breaking. I don't like these problems. They ask me to write them as a vertical addition problem. What I'm going to do is rewrite these problems. Each term I'm going to write in a nice order. So I really have to think of problem 28, or if I was doing I have to think of problem 28 as 2y squared minus 3y plus 5 plus, and I'm going to write this in a better order, minus 6y squared plus 7y plus 8. So I'm going to rewrite these problems as a vertical addition problem, but before I do that, I'm going to get the terms written in the proper order. And in my second parentheses, the terms weren't in the proper order. Now I'm going to make a vertical addition. The contents of the first parentheses is going to go above the horizontal line that has a plus on it. It's a vertical addition. And I'm going to write the contents of that parentheses above that vertical line with a gap. And then I'm going to write the contents of the second parentheses unchanged because of the plus sign in front of it. Second, and now I have the like terms lined up. The first like terms are 2 plus negative 6, so 2 plus negative 6. That y is going to have a negative 4. And then negative 3y plus 7y, negative 3 plus 7 is positive 4. I'm going to leave the y, and then 5 and 8 is 13. This seems silly to do, but every now and then you'll get a teacher in a higher class that just likes doing problems this way. So I just want to expose you to another way to do addition problems. The way that we did them seemed easy enough. This doesn't seem really pointed. But when we get into section 2.6, we'll do something like this, but it's a vertical subtraction, so maybe it's nice to see. In problem 30, each parentheses, the terms are written in a nice order. I'm going to take and write my vertical addition bar, put the contents of the first parentheses kind of a space above the division, the addition, the bar. This bar kind of is almost like an equal sign in some sense. And then the contents of the second parentheses with the implied coefficients of 1 underneath. So there's my vertical addition. First thing I need to do is negative 2 plus 1. Negative 2 plus 1 is negative, negative 2 plus 1 is negative 1. So I could either write negative 1x squared or just a negative x squared. I could suppress the 1. And then negative 3 plus 1 is going to give me minus 2x. And then negative 5 minus 2, because they have the same signs, I'd add them and get minus 7. So this is an acceptable answer. This is an acceptable answer. This is actually the more common answer, but this almost makes more sense to me. In problem 32, the first parentheses, I probably should think of it as 3x to the fourth plus 7x cubed plus 2x. The second parentheses, I should probably think of minus 7x to the fourth plus 6x cubed plus 3x. I'm going to write my vertical addition bar. First parentheses, I'll do 3x to the fourth plus 7x cubed. Maybe I'd leave a gap in a more complex problem where the right parentheses has an x squared term and the left parentheses doesn't, but no gap really necessary here. Right parentheses minus 7x to the fourth plus 6x cubed plus 3x. Then I need to do 3 plus negative 7. My first coefficient is going to be negative 4 in front of the x to the fourth. And then 7x cubed plus 6x cubed is 13x cubed. And 3x plus 3x is 6x. There's definitely stuff I can do to write this answer more sophisticated, but that's beyond where we're at right now. In problem 34, and problem 35, I have to worry because the parentheses are unbalanced. In my problem 34, the parentheses are written in a nice order. The first parentheses, which I write above the horizontal line with a space, I'd write like that. The second parentheses contents, I need to line up the like terms. The plus 3x and the minus 7, I probably didn't need the plus in front of the 3x because it's implied, but it's kind of nice to have. Now I'm going to bring down the 7x squared, there's nothing to combine to it, and then 5x plus 3x is 8x, and 3 minus 7 is minus 4. So that would be a perfect answer for problem 34. I'll try to leave 35 on the screen while I pull up 36 because they must be kind of clones of each other. In 36, my parentheses are written in nice orders. The first parentheses leads off with an 8z squared, a 5z, followed by a 4. The second parentheses has a cubed term. You'll notice that when I made my line for adding, I kind of indented the 8z squared because I want the highest power term to go first, and the highest power term has a different exponent. It can't be added to the 8z squared. So for the second line in my vertical addition, the 2z cubed doesn't line up under anything, the 3z lines up under the 5z, and the minus 5 lines up under the 4. So when I'm writing these vertical addition, I want the terms written vertically to be addable. So I'm going to bring down the 2z cubed, it's positive. I'm going to bring down the 8z squared. I need a sign, either an addition or subtraction between each term. Because the 8z squared is positive, I'm going to put a plus sign between. I'm going to add the 5z and 3z and get 8z. And 4 minus 5 is negative 1. When they have opposite signs, the numbers, you subtract and take the sign of the larger. So for problem 36, this would be the best answer. That should work a lot like your 35. Let me sneak out 38. I get a 1a squared if I want to emphasize the 1 as a coefficient in that first parentheses, plus 5a minus 9. And in the second parentheses, I'm going to line the 2a squared under the 1a squared. I'm going to line the minus 6 under the minus 9. I don't have anything under the 5a because there isn't a like term in the right parentheses. Adding my 1a squared plus 2a squared, I get 3a squared. And then bring down the plus 5a. The 9 and the 6 are both negative, so to combine those, I add the numbers and keep them negative. If the numbers are both positive or both negative, you add them. If the numbers are one positive and one negative, you subtract and take the sign of the larger. On my calculator, if I want to do minus by the fraction 9, minus negative by the fraction 9, minus by the equal sign 6, that would give me the negative 15 that I need. So this is probably a good place to stop because I wrote so many problems that I want to do a part 3.